What is up, mathletes? This is section 3.4, solving quadratic equations by factoring. What exactly is factoring? Well, I'll tell you what factored form looks like. It looks like this. Here's an example where you have one expression and then it's inside parentheses and you're multiplying it by another expression, and that's equal to 0. Just one giant term right here consisting of two different factors, and those factors have an exponent of 1 at the very highest. So you can see the exponent on this x is 1. And that's really important because we're going to use it in conjunction with something called the zero product property. So, and that goes like this. Here's the logic. If you have two numbers, I'm thinking of two numbers, and if you multiply those two numbers by each other, you get 0. Well, then if you know that's true, then either one of the two numbers that I was thinking of have to be 0. If a times b is equal to 0, then either a would equal 0 or b would equal 0. They'd have to, because when you multiply them, you get 0. So we're going to use these two ideas in conjunction with each other to help solve more complicated equations. That's what we're doing. We're solving quadratic equations. What's a quadratic equation? It's when the exponent is higher than 1, when the exponent is exactly equal to 2. So something like this here. Notice when you have 3u squared minus 15u, you actually can't just use your algebra 1 techniques. You can't just undo operations because the variable exists in two different locations. There's two instances of the variable. You couldn't just undo the addition and then undo the multiplication because there's just too much going on. It's too complex. But there is a greatest common factor of, say, in this case, 3u. I'm looking at this term and this term, and the greatest common factor of the numbers is 3, and the greatest common factor of the variables is u. So the GCF is 3u. And you're going to put it outside a set of parentheses here, 3u. And then you ask yourself, 3u times what gives you 3u squared? The leftover is u. 3u times what gives you 15u? The leftover is 5. The subtraction just comes on down. And then now it is in factored form, as we set up here. We have one term, or one expression times another expression equals 0. And because it's in factored form, we can use the zero product property. We can say that this times this would equal 0. So therefore, the two different expressions individually would have to, one of them would have to equal 0. So you could say 3u is equal to 0, or u minus 5 is equal to 0. And once you do that, now we're in a good place where we can undo operations like we did in Algebra 1. Now the equations are simple because they've been split into two different simpler equations. We can solve them. Undo the multiplication, undo the subtraction, and you get your two answers. The solutions are 0, and 5. You can express them in set notation like this. Let's do that again. Here, 4x squared plus 8x is all equal to 0. Well, the GCF is 4x, so I'm going to put it out here. And then you have to ask yourself, after you factor out the GCF, what are the leftovers? Here the leftover, 4x times what gives you 4x squared? It's x. 4x times what is 8x? Well, the leftover is 2, and that becomes its own set of parentheses. Now we're going to use because it's in factored form, we can use the zero product property to split it up into two different equations. You use your algebra 1 to solve them, and you get your two answers, 0 and negative 2. Here's another one. This one, you notice here, these were already set equal to 0, and that helped us because the zero product property requires that everything's set equal to 0. Everything is on one side of the equation, and just 0 is on the right. We don't have that at the beginning. So as a very first step, what you got to do is you got to move the 18w over. 6w squared minus 18w. Now it's equal to 0, and now you can put it in factored form. The GCF in this case is 6w, because I'm looking at the two terms, and I see a 6 in both, and a w in both. So I can pull that out, and the leftovers are w minus 3. Because 6w times what gives you 6w squared? It's w. 6w times what gives you 18w? It's 3. And so that's factored form. Now that it's in factored form, we use the zero product property to split them up, and now we can undo operations like we do in Algebra 1. Divide by 6 here, add 3 here, and you get your answers. All right. Let's move on to some more even complicated equations. So before, these were kind of like in the format of a squared, like there were two terms here and no number. In here, we're going to have three terms: a squared term, a linear term, and a squared term, a term that has an exponent of 1, and just a number here. It's really tricky because there's multiple instances of the variable, and they're not even like terms. You can't combine them. You've got an x squared term and just a regular term. So there's like three things here, three different terms, and they're all equal to 0. So I'm going to run through some steps. First of all, if it's not already equal to 0, you got to set it equal to 0. Second, you always got to check for a GCF. It's standard whenever you're factoring. The next one is going to be a process called split the middle, and this might be new. Splitting the middle looks like this. Well, let me do it through an example. So the first step would be to set it equal to 0. We've already got that. The second step would be to look at a GCF, and the GCF is 1. So we don't really have to do anything to change this equation for the first two steps. Split the middle looks like this. You first have to list the factor pairs of your C term. Like this C right here, it's 12 for me in this example. So I'm looking at 12, and I have to list all the numbers that multiply up to 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. The next in split the middle is choose the pair of these three different pairs. Which one of them also happens to add up to B? And see, I'm looking at these. The B value here is 8. So look at these. Oh, the 2 and the 6 also add up to 8. So what we're going to do now to split the middle is we're going to write out the next step, and this middle term gets split. Split the middle. Middle term gets split, and then the 8u becomes 2u plus 6u. Notice if you were to combine like terms, you'd get back to the original. But it's really important that we have these terms split, because now we have because the next step is going to require 4 terms. If we had started off with an equation that had 4 terms, we'd be able to go to this next step, which is box factor. And because we don't have 4 terms, we produce 4 terms. But this box factoring is you draw a 2 by 2 box, and it requires 4 terms. You just load them up into the box. It also requires that the 2 middle terms, like the 2 and the 6, multiply up to 12 and add up to 8. When you have that, and the last thing that it requires is the order. There's some flexibility, but I like to put my squared term here, my numbered term here, and the 2 terms that have been split from the middle here. And the actual order doesn't matter. You could put the 6u here or the 2u here. But when you do it like this, what you can see pretty quickly is when you do the greatest common factor of the 2 terms in the top row, you can put it here. That's u. And the bottom row, the GCF is 6. The GCF of the left 2 terms here is u, and the GCF of these 2 terms is 2. So you take the GCF 4 times of the top row, the bottom row, the left row, the left column, the right column. And when you do have these 4 different GCFs, then you can string them up into u plus 6 and u plus 2. What you've done here is you've reversed foiling. This is something you could actually foil back out and get to this if you wanted to. You know, this is the first terms would be u times u here. The outside terms would be u times 6, which is here. The inside terms would be 2 times u here, and the 2 times 6 would be 12 here. And you'd write them all out. This is foiling, going in the But what we want to do is we want to reverse foil. We want to take things that have been multiplied and figure out what their original. We want to insert multiplication here. So because we've reversed the foiling, we've got it into something that is a factored form. This is how you can produce something that's in factored form. And because it's in factored form, you use the zero product property to split it up. Then these equations are much easier to solve than the original. You can undo the addition in both instances and get your answers. Let's run through all that again and introduce a little more complications. All right. So here, You can see the first step is set it equal to 0. Boom. So we got to move these over to the other side. My preference is to keep this highest exponent term, the squared term, positive. I think it keeps everything. I could have just subtracted the v squared to this side, but I think it introduces more trickiness than it needs to. Move everything over to the other side and just keep this first term positive. So you get v squared minus v minus 12 equals 0. Check for a greatest common factor. In this case, it's 1, so nothing to do. I'll show you in the next example, the GCF won't be 1. Now we got to split the middle. And what you do is you look at the c value, which is in this case negative 12, and you have to write down all the factor pairs that multiply up to negative 12. You might think this is something you can do in your head, and maybe you can, but it's just more reliable to do on paper, so I highly recommend writing it out. You're just going to take your accuracy up when you write it out. So looking at negative 1 times 12 is negative 12. Negative 2 times 6, negative 3 times 4, negative 4 times 3, negative 6 times 2, negative 12 times 1. You can see some symmetry here. When you order it in this way, then you get the symmetry, and it's a lot easier to make sure you have a complete list when it's organized. So then you have to check to see which one of these also adds up to the b value. It's unwritten, but there's a 1 in front of this v, and so the b value I would say it's negative 1. So which of these also happens to add up to negative 1? It's negative 4 and 3. I'm going to take this minus v and split it up into minus 4v plus 3v. I'm taking these numbers here. What was 3 terms is now 4 terms, and 4 terms is great because 4 terms fit into a 2 by 2 box. You put this here, your box factor, so that you look like v squared is here and the minus 12 is here, and these two are kind of interchangeable. It doesn't matter what order they go in. Greatest common factor of the top row, v. Greatest common factor of the bottom row, 3. Greatest common factor of the left column, v. Greatest common factor of the right column, minus 4. And now you have what you can put into this format, v plus 3, v minus 4. This is factored form. Once it's in factored form equal to 0, you can split it up, v plus 3 equals 0, or v minus 4 equals 0. Undo the operations and you get your answers. Whew! That's a long process, but it's something that's doable, and if you're careful and you practice, then it's going to be super powerful in a lot of applications. Here, check this out. Okay, this is not equal to 0, so first step, got to set it equal to 0. Second step, check for greatest common factor. And in this case, I'm going to say that the greatest common factor is negative 3. You might say, it's just positive 3. Why choose negative 3? If you choose negative 3, then this first term turns positive, which I said indicated is a lot simpler to think about and deal with. So you divide all other terms on both sides of the equation by negative 3, and all of a sudden the numbers get much smaller. You could actually split the middle with this. Like if you didn't divide them all by negative 3, the process would still work, but the numbers in this case get a lot smaller and a lot easier to work with, and of course the studentship gets a lot easier. And when that happens, then you're more likely to get the answer right. So we're going to divide everything by negative 3, and this is what you get. Now the c term is 10, so I got to list the numbers that multiply up to positive 10, and it's 1 and 10 and 2 and 5. But none of them actually add up to the b value, which is negative 7. So what I can do is I can also continue and just say, negative 1 and negative 10, and negative 2 and negative 5. Take these and just add some negatives. They still multiply up to positive 10. Negative 1 times negative 10 is positive 10. Negative 2 times negative 5 is still positive 10. But now we found something that also happens to add up to negative 7. So I'm going to take this minus 7x and turn it into minus 2x minus 5x. They're still equivalent, the same kind of equations, but now we have 4 terms. And 4 terms go into a box, a 2 by 2 box. Put the x squared term here, the 10 here, and these two are interchangeable. Greatest common factor of the left column, greatest common factor of the right column. Greatest common factor of the top row, greatest common factor of the bottom row. And you get these 4 different greatest common factors. You can put them into factored form, and this is something we've just reversed FOIL. So if you were to FOIL this out, you'd get this and you get this. But we're going in the opposite direction of FOILing so that we can get to this factored form, which is great because now we can use the zero product property to split them up into 2 different simpler equations that we can solve. When you solve those equations, you get your answers. Whew! That's a whole lot. Let's keep going. What are the solutions? Here, let's do the same thing. let's do the same thing. You've got an equation you need to solve. Let's split the middle. Negative 45 has these factor pairs. Negative 1 times 45, negative 3 times 15, negative 5 times 9, negative 9 times 5, negative 15 times 3, negative 45 times 1. Look at this organized list. I can tell it's complete because it's organized. And now I got to find all these factors pairs, I got to find the one that also happens to add to negative 4. That happens to be this one right here. So we split the middle, and we get minus 9x and plus 5x. And now we have 4 terms. 4 terms fit into a box. It's a 2x2 box. X squared, negative 45, and then these 2 terms can be on either side. Doesn't matter. But we get the greatest common factor of the left column, greatest common factor of the right column, greatest common factor of the top row, greatest common factor of the bottom row, and we get the numbers and expressions outside. X plus 5 goes here, x minus 9 goes here. And factored form splits up into equations we can solve, undo the operations, and get your answers. Now, you might, that's what we've just practiced. What are the solutions? And you can now find the solutions. But you also might ask, the question might ask us, what are the zeros of this function? It might give you a function. Notice this equation and this function are very similar. And if it asks you what are the zeros of the functions, it's really saying what x values will produce a value, an output of 0. Like what x produces an f of x, like what input produces an output of 0. So really this function turns into this equation because for some value of x you're going to get a 0. But look, it's going to be the same as this over here. You're going to do the same process in order to find the zeros of the function. You do the same thing over here, and you get negative 5 and 9. That means negative 5 is an input, and 9 is also an input, so that when you put them into the function, you should get 0 out. You can check that with the graphing table right here. You see, when the x value is negative 5, you run it through, and you get an output of 0. When 9 is here, you run it through, and you get an output of 0. Whew. All right. Next, the question also might ask, what are the intercepts of this graph? And so you might have an equation that looks like this, but really what you want to know is what value of x will have a y value of 0. That's where the x-intercept. The x-intercept occurs where y is equal to 0. You see, fast forward to the answer, it would look like this on the graph. X-intercepts have y equals 0. But we want to know, if we didn't know what the graph looked like, we would say, well, I don't know what x is, but I know that y is equal to 0, and we're left with this equation. You do the same process and get the same solutions, negative 5 and 9. The big idea of what I'm really trying to say is equations have solutions, functions have zeros, graphs have x-intercepts, but you can put them all into factored form and find them all. So if you want to find the solution to an equation, factor. If you want to find the 0 of a function, factor. If you want to find the x-intercept of a graph, factor. They're very, very related ideas, but use all the same process. All right, next, let's reverse this whole thing. So if the instructions say start with the solutions, write the original equation in polynomial form, not factored form. But polynomial form means basically had no parentheses. You're going to reverse those steps. If they give you x equals 5 or x equals negative 3, which was the last thing, like this is basically the answer to a question like this, right? U equals negative 2, U equals negative 6. That's the last thing. What's the first thing here? First thing. So let's unsolve. Let's reverse step number 6. Step number 6 was solve the individual equations. Well, let's reverse that. Let's bring the 5 back over. Let's bring the 3 back over here. And then let's join those two different equations into one complicated equation. This is now factored form. We use the reverse. We reversed zero product property to get this. And then to get rid of the parentheses, we have to FOIL. We FOIL it all out, and you get this. You could use a box, a 2x2 box to help you FOIL, but however you FOIL, this is what the answer is. Notice this is what we would have started with earlier, and we reversed the process. Because sometimes you want to take these numbers and produce one polynomial, that one expression that looks like this in an equation. Let's reverse the steps again. So we got this. Let's unsolve it. Let's set them equal to 0. And because they're equal to 0, you can use the zero product property in reverse to join them together. Then you can FOIL it, and you get this. And I'll let you figure out once you FOIL, you get this. I'll let you figure out what the last term is under the red dot. And speaking of red dots and Edpuzzles, I just wanted to say that it's around Halloween right now that I'm doing the recording, and my favorite ever group costume was all my buddies and I, 12th grade, senior year. We all got together, like 6 or 7 of us, and we were all Addams Family, and it rocked. We totally, everyone was taking photos, and it was great, and they put it on the yearbook. So, and I was the father of the family. I was Gomez because I was the most dramatic, I guess. It was really fun. All right, so here we go. X equals 1 or X equals 0. Again, unsolve this first one to set it equal to 0, and then join them together, and you get X minus 1 times X equals 0, and then FOIL, or not FOIL, distribute, and you get this. All right, y'all, thanks for paying attention. It's been real. I can't wait to see you in class, and take care.